Okay, in this video, we are going to go through the Unit 12 review. A few things before we get started. One, you will have Desmos. Make sure you're in degree mode for this test. So in settings, you want to go down and make sure that degrees is selected. A couple other things. Both of these formula sheets are linked in the class Google Sheet. This is the one that you will get to use on the test. It just kind of has all the formulas there. So familiarize yourself with that. But basically, any formula that is needed for this test is given. And then I gave this out in class, but it's also linked in the Google Sheet, and it is a reference for how to solve triangles. You will not get this on the test, but I would take a look at it because I really break down the difference between solving a right triangle and solving a non-right triangle, when to use law of sines versus when to use law of cosines. I kind of give you the shortcuts for how to plug things into the calculator, which is very helpful if you know those, and I'll do that as I'm working through the review today. You'll see how it's just really easy if you understand the shortcuts to do that. Okay, and then I also have 4 examples of solving triangles there. So you might want to take a look at that at some point in time before you take the test. The first 4 questions are to convert between degrees and radians. If you're going to go from degrees to radians, you want to multiply by pi over 180. What I would do is I would do the degree measurement over 180 in a calculator, and it will reduce that, and then attach the pi to it. So plug that into the calculator, do not plug pi into the calculator, and then reduce. So if I did negative 100 divided by 180, click the fraction button, it's going to be negative 5/9, and then I would attach the pi to it, so negative 5 pi over 9. Same thing for number 2. When we're going from radians to degrees, we multiply by 180 over pi. What's going to happen here every time is that the pi's will cancel each other out. So really all I need to do is 2/3 times 180, and that's exactly how I would plug that in. To the calculator, I would just do 2/3 of 180, which is going to be 120. That means our answer is 120 degrees. Okay, so those should be pretty easy, and again, you're given what to multiply by there. Arc length, we've got S equals R theta. This angle, theta, needs to be in radians. That does not mean that your calculator has to be in radian mode. The time the mode matters is when you are doing trig functions, and we're not doing any trig functions here. Okay, we're just using an angle, but the angle needs to be in radians. So for number 5, we would just do the radius times the angle in radians, which would give us 11 pi over 4, and then we do want to have the unit there, kilometers. If, like on number 6, you have an angle that is in degrees, you would want to convert that to radians. You could either use the conversions like listed in questions 1 through 4, or if you had a unit circle, you would know that 150 degrees is the same as 5 pi over 6, and then I can use my formula. So I would do 15 times 5 pi over 6, and then what I would do is I would don't put in the pi, do 15 times 5/6, which would give me 25 over 2, and then attach the pi to it. 25 pi over 2 kilometers. Next 2 questions deal with area of a sector. Again, that formula is also given, 1/2 r squared theta. So area equals 1/2 r squared theta. Again, theta needs to be in radians. So if it's given in degrees, we want to change that to its radian equivalent, which would be 3 pi over 2. And then we're just going to plug everything into the formula. 1/2 times the radius squared times the angle in radians. What I would do to plug this into the calculator, I would just plug in everything except for the pi. Right? So I would do 1/2 times 16 squared times 3 over 2. 1/2 times 16 squared times 3 over 2. That gives me 192, and then I attach the pi. So this is going to be 192 pi. And since we are finding area, it's unit, which is yards squared. Same thing on number 8, you would do the exact same formula. I don't need to change my angle, it's already given to me, so I'm going to do 1/2 times 8 squared times 7 pi over 4, plug that into the calculator, and get your answer. Units would be kilometers squared. Okay. Next up we have area of a triangle. These formulas are given as well. If you notice, we have area of a formula. There are 2 different formulas for this. We have this one, and we also have what is called Heron's formula, which is this one. The first formula you want to use if you are given 2 side lengths and the angle in between. So it doesn't really matter. They don't have to be called A and B. Okay, so if I'm given, say, some side length here, another side length here, and I have the angle in between, then I want to use this formula. You want to use Heron's formula if you have all 3 side lengths. So I don't have any of the angles, but I can find the area of that if I'm given all 3 side lengths. So on the review here, I've given you one of each. The first one, I give you one that has 2 side lengths and the angle in between. So I would want to use 1/2 AB sine theta. So I would do 1/2 times 10 times 11 times the sine of 105 degrees. I would just plug all of that into the calculator. 1/2 times 10 times 11 times the sine of 105. And that gives me 53.1. If you're concerned about rounding, sometimes it says what you want to round to, but I actually don't care. I'm just going to say round to what makes sense. So we got 53.1. If it makes more sense based on the numbers to round to the nearest 100th or to the nearest whole number, do that. That's fine. We're finding area, so this would be feet squared. Make sure you put the unit there. If you are given all 3 side lengths, you want to use Heron's formula. The first thing you have to do with Heron's formula is find what is called the semi-perimeter. That's what your S is, and that is just half the perimeter. So what I would do first is I would do half of the perimeter, which would be 7 plus 11 plus 6. And that's going to give me half of 1824, which would be 12. And then the formula is, if you look at this, it's S, and then we're going to multiply by S minus each side length. So I would do 12, and then I would do 12 minus 7, 12 minus 6, and 12 minus 11. The order does not matter, but I would just plug all that into the calculator, and it will calculate that for you. So do the square root of 12 times 12 minus 7 times 12 minus 6 times 12 minus 11. 18 point, so I could do 18.97. I could do, if I round to the 10th, that's actually just going to round it up to 19. So round to what makes sense is kind of my rule of thumb here. I'm just going to say 19 squared centimeters. Okay. After that, we get into finding trig functions of angles. So this is just a SOHCAHTOA problem. If I want the sine of theta, sine is opposite over hypotenuse. Here's theta. I don't have the opposite side length. I have to figure that out. I do have the hypotenuse. It's 20. So to find out that side length, I would just need to do the Pythagorean theorem. The hypotenuse is 20. So I'm going to do, really I'm doing 12 squared, let's call this x. I'm really doing 12 squared plus x squared equals 20 squared. The shortcut is I would just subtract this over here and take the square root of it, right, to get x. So if we do that, the square root of 20 squared minus 12 squared, that's going to be 16. So this side length here is 16, which means that the sine of the angle theta is opposite, which is 16, over hypotenuse, which is 20. If you want to, you could reduce that, divide that by 4. That's going to be 4 over 5. You do not have to find the angle. It's just find the value of the trig function. So when the directions are to find the value of the trig function, it's just saying leave it as sine theta, and you're just writing the SOHCAHTOA relationship. That is your answer. Okay. I'm going to stop this video here. The next, from 12 through 16, are all solving triangles. So I want to talk specifically in the second video about solving triangles. The first one is going to be a right triangle. I see a right angle there. The rest of them are not going to be right triangles, so I'm going to have to use law of sines or law of cosines. The majority of your points on this test will come from this solving triangles portion of the test. So I'm going to pause the video here, pick up with the second video with number 12, and we are going to solve triangles. That's going to be the meat of the points that you're going to get on the test.